Hi, my name is Chung Cheang, and today I'm gonna present for assignment 3. For question 1, the question 1 answer is A. State the energy balance associated with the system. So the answer is E, energy in minus energy out equals to theta changes of E system, where the E in is Q in and the E out is work WB out equals to changes U internal energy equals to M mass time in bracket internal energy minus final internal energy minus initial internal energy, and the answer is Q in equals to mass bracket final internal energy U minus initial internal energy U1 plus work B out. And B answer is show the process on a PV diagram. The given data is the P1 200 kilopascal and the P2 equals to P3 is 400 kilopascal, and mass is 3 kg and the temperature is 27 degrees Celsius, which we convert plus 273 Kelvin equals to 300 Kelvin. From the graph we can see that the pressure from pressure 200 kilopascal and is the same to V1 equals to V2, and the second one is the 400 kilopascal where it's going up to the second dot and then straight to the constant line in the third one, which is V3. And for C, to determine the final temperature of the air, know that P1 times V1 equals to MRT. The V1 is equal to MRT over P1, which the M is mass 3 kg times R is 0.287, and the T1 is 300 kilopascal over P1 is 200 kilopascal, and the V1 is equals to 1.2915 meter cube, and the final velocity, final volume is equals to 2 times initial volume, which is 2 times 1.29, and we got the final volume is 2.58 meter cube. And then to find the final temperature, we use the formula of P1 times T1 over V1 equals to P3 times T3 over V3, which the temperature, final temperature, we P1 P1 over V3, P1 times V3 over P1 times P3 over times V3 over P1 times V1, which is time T1, which the 400 kilopascal over 200 kilopascal time 2 over 1 times 300 kilo 8 Kelvin, which we got the final temperature is 1200 Kelvin. For D, determine the work done by the A. WB out equals to integration of P dV, where it's this P3 times bracket the volume, final volume minus initial volume, which the P3 is 400 kilopascal times final volume is 2.58 minus initial volume 1.29, and the answer for work done is 516 kilojoule. And for E, to determine the heat transfer to the air during the process, we know that from T1 300 kilopascal, the initial internal energy is 214.07 kilojoule per kg, and for T3 equals to 1200 Kelvin, and its final internal energy is 933.33 kilojoule per kg. So to find the heat transfer, we know the formula is Q in equals to mass time bracket final internal energy minus initial internal energy plus work done out, which is 3 kg time internal energy, the final internal energy 933.33 minus 214.07 kilojoule per kg plus 516 for work done, and we got the heat transfer is 2674 kilojoule. For question 2, answer is to find the heat. Heat. So first thing first, we convert the diameter, which using the area pi d over 2 square. The diameter is 0.08 over 2 whole of 2, and we got the 0.005 meter square. And the m dot is mass flow rate time density 0.07833 kilojoule per meter cube time volume velocity 0.03 meter per second time area 0.005 meter square, and we got 1.17495 time 10 power of -5 kilojoule kg per second. And then the Q in equals to m dot Cp times Cp times changes of temperature, which we got is 1.17495 times 10 power of -5 kilojoule per second, which is mass flow rate, and the Cp is 0.465 kJ per kg degree Celsius, and time the changes of temperature, the final temperature is 500 minus the initial is 30 degrees Celsius, and got 202.568 times 10 power of -3 kJ per second, and then we convert it to kilowatt, which is 2.568 times 10 power of -3 kilowatt. That's it for me.